Now let's start doing the derivation of unit step response of a second order system. Okay. Now, for this we are going to consider an underdamped signal, that is where eta value is less than 1. For this, consider the characteristic equation s square plus 2 eta omega ns plus omega n square. This is equal to 0. This is the characteristic equation of the second order system. Okay. Now we have to find the roots for this. It has two roots. Okay, they are s of 1 comma 2, where it is equal to minus eta omega n plus or minus square root of 1 minus eta square to j omega n. Okay, this is the roots. It can be written as s of 1 comma 2 is equal to minus eta omega n plus j omega n square root of 1 minus eta square. This is one root, and another root is minus eta omega n minus j omega n square root of 1 minus eta square. Next we have to assume or let eta omega n is equal to alpha, and then omega n square root of 1 minus eta square is equal to omega d. This is nothing but damped frequency oscillator. Damped frequency of oscillation. Okay. Now let's substitute these two values in the roots whatever we have got. So it is equal to minus eta omega n is nothing but minus alpha plus or minus this omega n square root of this is nothing but j into omega d. This entire value I'm going to substitute by using this. So your roots is equal to 1 minus plus or minus j omega t. Okay. Next, for a unit step function, what is step input? What is r of s? Which is nothing but 1 by s. So now what we are going to do is, now c of s by r of s is equal to omega n square by s square plus 2 eta omega ns plus omega d square. This is my characteristic equation. Now what I am going to do is, c of s I will keep it here, which is equal to, I am going to write omega n square by r of s into s square plus 2 eta omega ns plus omega n square. What is r of s now? It is equal to 1 by s. So your c of s will be equal to omega n square by s into s square plus 2 eta omega ns plus omega n square. Now we are going to take the partial fractions. Okay. Then c of s is equal to, I'm going to write it as a1 by s plus a2s plus a3 divided by the denominator term s square plus 2 eta omega ns plus omega n square. Okay. Now this is the, now what we are going to do, take LCM. C of s is equal to, denominator is s into s square plus 2 eta omega n s plus omega n square. The numerator, what it will happen, a1 into s square plus 2 eta omega n s plus omega n square plus s into, this s will go a2s plus a3. Now what is C of S? C of S is nothing but this one what we have got. Okay. Now let me write that. Omega n by S into S square plus this omega n S. C of S value I am going to write here. S square plus 2 eta omega n S plus omega n square is equal to a1 into s square plus 2 eta omega n s plus omega n square plus s into a2s plus a3 divided by s into s square plus 2 eta omega n s plus omega n square. Now what will happen? The denominator terms are common, so it will get cancelled. So now we are going to have equate the numerator terms only. Omega n square is equal to a into a1 into s square plus 2 eta omega n s plus omega n square plus s into a2 s plus a3. Now we will split this terms. Multiply a square plus a1 2 eta omega ns plus a1 omega n square plus s into a2s plus a3s. This is s square I will write. Okay, a2 s square. Okay, now all the s square terms you separate. S square into a1 here 1s square, here 1s square plus a2, then what I have, s term I have plus s, open the bracket, what I have is 2 into a1 a1 eta omega n plus this term, next s term is this one plus a3 this one plus a1 omega n square. Okay, just you are going to group them. Okay. Now what you are going to do, to the LHS I have omega n square. Now omega n with non-s term you group. Here one non-s term, here one non-s term. Nothing but a1 omega n square. Omega n square cancel. Therefore, a1 is equal to 1. a1 is equal to 1. Next what I have to do is equate s terms. S term what I have, a1 plus a2 which is equal to the LHS I don't have anything, so it is 0. a1 I got it as 1. a1 is 1. So a2 is equal to minus 1. This is s term. Now group s square terms and equate it to LHS. S square term is This is s square term, this is s term. Okay, s term what I have? A1 2 into eta a1 omega n plus a3 is equal to 0, because your LHS you don't have anything. So a1 is equal to 1. So 2 into 1 into eta omega n plus a3 is equal to 0. 2 eta omega n plus a3 is equal to 0. a3 is equal to minus 2 eta omega n. This is a3. Okay. Now substitute these partial values in the partial equation whatever you have got. C of s is equal to a1 by s plus a2 s plus a3 divided by s square plus 2 eta omega ns plus omega n square. This is what you got, no? Now let's substitute this value. C of s is equal to a1 is in by s plus a2. a2 is minus s, minus 1 into s, plus a3 is minus 2 eta omega n divided by s square plus 2 eta omega ns plus omega n square. Now C of s is equal to 1 by s plus minus of s plus 2 eta omega n divided by s square plus 2 eta omega ns plus omega n square. Okay. Now what we will do, C of s is equal to 1 by s minus s plus 2 eta omega n divided by s square plus 2 eta omega ns plus omega n square. What did I do? This minus sign, I took it here. Now we know that alpha is equal to eta into omega n. Omega d is equal to omega n square root of 1 minus eta square. That we will substitute in this above equation. Okay. Now you say me C of s is equal to 1 by s minus s plus 2 eta omega n will become alpha divided by s square plus 2 alpha s plus omega n square. This is what now we got after substituting. Now we are going to find the roots. So what we are going to do, consider the second term. This is s into alpha s plus omega n square. Take this last term. Okay, I have to make it in such a way that I'll add something, subtract something, even then the original value should not change. How to find out what value I should add? For that, I'm going to, in order to add the last term, this last term I want, which is nothing but middle term of that square divided by first term. Okay, here this last term is nothing but middle term is what? Middle term is 2 into alpha, the whole square divided by first term is 1. 4 into 4. It is 4 into 1, which is nothing but 4 alpha square divided by 4. So alpha square is the last term which I am going to add and subtract. So s square plus 2 alpha s plus alpha square plus omega n square minus alpha square. Now I added and subtracted alpha square. What does it mean? It doesn't change my original value. Now it looks in which form? S plus alpha the whole square form. plus I have omega n square minus alpha square. Okay. Now, what is alpha? It is nothing but eta into omega n. Alpha square is nothing but eta square into omega n square. Mhm. Now, s plus alpha the whole square plus omega n square. For this equation, I am going to substitute this alpha value minus eta square omega n square. This term I am going to add here. Now, s plus alpha the whole square plus omega n square, I'll take common. It is 1 minus eta square. Now, what is omega d? Which is nothing but omega n square root of 1 minus eta square, which we know. Okay. Now, I want omega d square, which is nothing but omega n square root of 1 minus eta square, the whole square. So, the square roots will get cancelled. Omega d square is equal to omega n square into 1 minus eta square. Okay, this is the value of omega d square root. Okay. Now you substitute this value in our C of S. What is our C of S is equal to 1 by S minus, I am going to write the C of S again so that I can show you here. S plus 2 alpha, which I have got it in the previous page, S square plus 2 alpha S plus omega n square. This is what I have got it in the previous page. Now we are going to add and subtract those or insert those values. Okay, which is equal to 1 by S minus S plus 2 alpha divided by, here what I'll have, what did I do with this equation? I added and subtracted with alpha square. What did I get? I got it as S plus A alpha the whole square. That value I got. S plus alpha the whole square plus omega d square. That is what I got there in the previous page. See here, we have done it right. Let's substitute and we got this value. Okay, now S plus alpha the whole square. What is this omega square into, which we have found out now? It is omega d. So for this I am going to substitute it. S plus alpha the whole square plus omega d square. This is now the equation which in place of, for what? The characteristic equation which we have done it. This characteristic equation. For this we got it in this form now. That we have to substitute here. That's what we have done here. Okay. Now what I am going to do, I have to learn some trigonometry values. That is nothing but Laplace inverse of S plus A divided by S plus A the whole square plus omega square. This is one Laplace equation. Okay. This is the inverse Laplace transform for this term is nothing but e to the power of minus at cos omega t. This is one all you have studied in your trigonometry. Similarly, L inverse of omega by S plus A the whole square plus omega square. This inverse Laplace transform is e to the power of minus at sin omega t. Using these two inverse Laplace, we are going to solve this problem further. Okay, now consider this. You are going to split this in such a way that, okay, 1 by S. Okay, this I am going to split it as S plus alpha divided by S square plus alpha the whole square plus omega d square plus alpha divided by S plus alpha the whole square plus omega d square. See, this formula is now divided into 2. Okay. Now coming. Now let me see whether it is in standard form or not. 1 by s. Okay. First term you check. S plus alpha. See here. S plus a divided by s plus a the whole square plus omega square. This format I want. Is this there? S plus a by s plus a the whole square plus omega square. So this entire term I can write it as e to the power of minus 80 cos omega t plus check now this whether this is in the standard form, this form. Omega should be in the numerator divided by s plus a the whole square plus omega square. Is this in that form? No, we don't have omega term, so we have to put omega term. For that what we are going to do, multiply and divide by omega d, numerator and denominator. So omega d divided by omega d into s plus alpha the whole square plus omega d square. Now what I will do, 1 by s into e to the power of minus 80 cos omega t plus this alpha plus omega d, I'll take it out, into omega d by s plus alpha the whole square plus omega d square. Now I got this. Okay. We now check whether this is in standard form. Omega by a plus s plus a the whole square plus omega square. Yes, omega divided by s plus a the whole square plus omega square. Now I got it in the standard form. So now what I will do, I can write that as this is equal to 1 by s into e to the power of minus 80 cos omega t plus alpha by omega d into that one I can write that e to the power of minus 80 sin omega t. Okay, now I substituted that value here, I got it in this form. Okay, now what I'm going to do, 1 by s, I will keep it as it is. Okay, now everything is in t form, so the c of t will become, now take inverse, the already we started taking inverse Laplace. So 1 by s inverse Laplace, what it will become? It will become 1. C of s will become c of t. 1 minus e to the power of minus 80 cos omega t plus alpha by omega d into e to the power of minus 80 sin omega t we have got. Okay, now what we have to do, wherever alpha is there, put eta into omega n, and omega d is nothing but omega n square root of 1 minus eta square. This we are going to substitute here. So your c of t will become equal to 1 minus e to the power of minus eta omega n t into cos omega t plus eta omega n, this alpha value, divided by omega d is omega n square root of 1 minus eta square into e to the power of eta omega n t into sin omega t. Just to substitute this value in the equation. Okay. Now what I will do, let me take out some common term, that is 1 minus, I will take out e to the power of eta omega n t as common, but then I will get cos omega t plus omega n cancel, then I will get eta by square root of 1 minus eta square, this has come out, then I will have sin omega t. I wanted it in some constant form, so 1 minus, I will take this eta omega n t divided by square root of 1 minus eta square, I will take it out. When I take it out, I have to, this will become 1 minus eta square cos omega t plus eta into sin omega t. Okay, this is what we will get now. Now this I can compare it one standard form, sin of omega d t plus theta, which is nothing but sin omega dt into cos theta plus cos omega dt into sin theta. This form I should get. I should check whether I have it in this form. Okay. Now C of t is equal to, it is in that form, right? 1 minus e to the power of minus eta omega nt by square root of 1 minus eta square into, first I want sin omega t value. Sin omega t means this one. Eta sin omega t. Next plus square root of 1 minus eta square cos omega t. Now we brought it in the standard form. So this I can write it as sin omega dt plus theta. This is in this form only, right? So I can write it as sin omega d into theta plus theta. So now my C of t expression, how it will become? C of t is equal to 1 minus e to the power of minus eta omega nt by square root of 1 minus eta square into sin of omega dt plus theta, because that was in a standard form. Okay. Now from this standard form comparison, come back here. See here. Compare these two. Okay, omega dt is there. Okay, omega dt is there, omega t. So what is eta now? Eta is cos theta. Eta is cos theta. Next, cos omega dt is there, cos omega t is there. Okay, this is common. So what is sin value now? Sin value is square root of 1 minus eta square, that we are going to write here. On comparing with the standard form, you got cos theta and sin theta value. Okay, cos theta is equal to theta, sin theta is equal to 1 minus eta square. So what is tan theta formula? Tan theta is equal to sin theta by cos theta. So on substituting, square root of 1 minus eta square by eta. So now tan theta formula is square root of 1 minus eta square by eta. Theta is equal to tan inverse of square root of 1 minus eta square by eta. This is theta value. This is tan theta value. This is the full derivation.